When astronomers from the Atlas Observatory first detected an object with an unusual velocity and angle of entry, no one imagined that within weeks it would become one of the most discussed mysteries of modern space. They gave it a simple name, 3I Atlas, the third confirmed interstellar object to enter the solar system. But what seemed like just another comet quickly turned into something more. Each new day of observations yielded conflicting data, as if nature itself were trying to confuse those observing it. It all started with the trajectory. Its shape was hyperbolic, which is not uncommon for interstellar bodies. But the angle of entry was such that it seemed the object had followed a perfectly calibrated route, calculated to within minutes. It didn't just enter the plane of the ecliptic, it almost aligned with it, deviating by less than 5 degrees. The probability of such a coincidence for a random body is about 0.1%. If someone wanted to send a probe to observe the solar system, remarked Professor Loeb, they would have chosen exactly this trajectory. And although his words provoked a storm of criticism, the statistics remained stubborn. 3I Atlas behaved as if it had a purpose. NASA officially stated, "This is an active comet with evidence of evaporation of ice and gases." Their data show a nucleus approximately 2.5 kilometers in diameter, surrounded by a dust cloud, which fits perfectly with conventional models. However, reports published later revealed that the evaporation rate was almost twice as high as predicted. Moreover, the mass loss was uneven. Periods of acceleration alternated with stable phases, as if the process were controlled internally. Physicist Michio Kaku called 3I Atlas a test for humanity. In an interview with the BBC, he said, "If it turns out that the comet's acceleration is caused not by thermodynamics, but by a controlled release of energy, we'll have to admit we're not alone." He emphasized that this isn't a statement, but a challenge. Science must be prepared for the fact that not all objects in the universe are natural. Astronomers from the ALMA Observatory added a strange detail: the comet's brightness fluctuated in a wave-like pattern, unrelated to solar heating. During periods when the temperature should have been decreasing, the brightness actually increased. One specialist described this as breathing, pulsations of light, as if the object were responding to something external or had an internal energy source. This could have been a gas outburst, but the tail's shape remained too symmetrical, as if the gas was escaping in a targeted manner rather than randomly. Since its discovery, 3I Atlas has flown hundreds of millions of kilometers, leaving behind a fine trail of dust and ice that stretches for tens of thousands of kilometers. But this trail, it turns out, is unusual. Spectral analysis reveals nickel, carbon dioxide, and cyanide, a mixture rarely found in such a combination. Some researchers felt they were looking not at a comet, but at something fused, artificially created. After all, such proportions are characteristic not of icy bodies, but of industrial alloys. However, every fact has a second explanation. NASA astrophysicists argue that the high nickel content may be a result of the object's ancient origin. It formed in a region with a different chemical composition, where the star enriched planetary disks with heavy elements. This makes 3I Atlas a valuable sample of interstellar matter, revealing processes that occurred in other systems. But if this is true, then we are looking at an object older than Earth itself. The way it reflects light only adds to the confusion. In the near ultraviolet, 3I Atlas's brightness was higher than expected, and the reflected light was blue shifted, almost like that of metallic bodies. Comets in our solar system, by contrast, reflect a reddish spectrum due to carbonaceous dust. This means the surface of this nucleus is either covered in high albedo minerals or has a metallic-like structure. And if it is metal, the question of its origin becomes much more serious. Some scientists cautiously recall the first interstellar visitor, Oumuamua. Back then, they also argued that evaporation couldn't explain its acceleration. Then the theory shifted. Supposedly, the body was covered in an insulating layer of nitrogen or hydrogen, which evaporated in a special way. But that theory too remains unproven. And now we're seeing similar behavior again, only on a larger scale. Is it a coincidence that two such rare objects exhibit the same anomalies within a decade? When Michio Kaku talks about the possibility of artificial origin, he doesn't mean a crude ship. He's talking about something bigger, technology that could have been created millions of years ago and is still wandering between the stars. In his lecture, he compared it to a bottle dropped into the ocean of the universe. If a civilization is old enough, it could send messages not through radio signals but through matter itself. And if 3I Atlas is such a message, it has been delivered. But is this a code capsule drifting aimlessly, or the wreckage of a world destroyed in a catastrophe? There are no answers yet. NASA plans to continue observing the object until it passes beyond Jupiter's orbit. After that, it will disappear from most telescopes, and all that will remain is data that will take decades to decipher. Meanwhile, 3I Atlas flies through space, rotating on its own axis at a rate scientists still haven't determined precisely. Its path is a story told without words, and perhaps one day we'll understand what it truly wanted to tell us. With each new measurement, 3I Atlas's behavior became less and less like a classic comet. Typically, as it approaches the sun, its tail lengthens and then gradually fades as the core cools. But here, the opposite dynamic was observed. The glow intensified after perihelion passage, as if some internal system maintained activity even as the heat source began to weaken. NASA labs explain this as the result of an inertial ejection, but data from the SOHO satellites showed that the changes occurred abruptly, as if triggered by a signal. And if it truly was a signal, then who was it intended for? Some astrophysicists see this as natural chemistry. Others see it as a pattern. Professor Avi Loeb of Harvard University wrote in his column in Scientific American, "Every time the data doesn't fit a pattern, science gets a chance to grow. 3 Atlas may turn out to be a mirror reflecting our fears and hopes simultaneously." He doesn't claim it's a spacecraft, but he points out that when Oumuamua flew by, the scientific community's reaction was almost the same: denial, then caution, then recognition that some observations couldn't be explained. And if the second interstellar visitor behaves strangely, and now a third is repeating the anomalies, that's a pattern, not a coincidence. In August 2025, the ALMA and Gemini South observatories recorded that the tail of 3I Atlas expanded by more than 100,000 kilometers in just 2 days. Such a rate had never been observed for any known comet. Some scientists attributed this to a high proportion of CO2. Molecules of this gas expand explosively when heated, creating flares. But spectroscopy revealed other lines, the presence of nickel and rare alloys. Such compounds don't form in the cold regions of space where comets are born. They require temperatures of thousands of degrees. So where did the metal come from? Perhaps 3I Atlas is a fragment of a planet that survived a catastrophic event, or a piece of a technological object melted to a mineral state. This is precisely the hypothesis Michio Kaku advanced. In one of his speeches, he said, "If you see a body whose velocity exceeds all known natural limits, whose acceleration doesn't match gravitational, and whose material exhibits an anomalous composition, you must consider the possibility of artificial origin. And not because it's beautiful, but because it's science." His words provoked a strong reaction. Some colleagues considered them too bold, but this is precisely what got the public talking. What if 3I Atlas really is a spaceship? This idea is supported by the strange synchronous brightness fluctuations recorded by the Hubble Space Telescope. Over the course of 40 minutes, the light intensity varied with a clear periodicity, as if the object were rotating at regular intervals, revealing smooth and rough surface areas. If it were simply a rotating body, the pulsations would be random, but here there was a rhythm. Everything was happening too smoothly. NASA did not comment on these observations, only adding that further analysis is required. At the same time, reports from private research centers noted that the angle of light scattering from the tail does not align with the direction of the solar wind. Normal comets always have tails that deviate from the star, but in August 2025, 3I Atlas formed a reverse tail. Some of the dust and gas was moving in the opposite direction. This meant that it was subjected to a force unrelated to light pressure. Such an effect has only been observed in laboratory plasma emission experiments, where magnetic fields direct particles against the solar flow. Scaling up this process could produce thrust. European Space Agency scientists have cautiously suggested that localized electromagnetic activity, residual currents or plasma arcs, created by the friction of charged particles, may exist on the surface of 3I Atlas. However, in informal discussions, astronomers have referred to this as an engine signature. Even if the engine is natural, we still have to understand its principles. It would seem that all this could be explained by chemistry. The ice evaporates, the gas expands, and the comet accelerates. But a key question remains: why is the acceleration constant and not chaotic? With natural evaporation, the thrust should vary. Here, however, the growth rate remained constant for several days. Professor Richard Dennison of the Princeton Aerodynamics Laboratory suggested that the comet's behavior resembles a pulsed ejection system. Brief series of shocks, like a jet engine. If 3I Atlas were a solar-powered spacecraft, this is exactly what it would look like. But if this is truly technology, who owns it? Perhaps it's the remnant of an ancient civilization that vanished millions of years ago. Perhaps it's the result of a natural evolutionary process, technologies that developed independently of organic life. Michio Kaku calls such hypothetical forms of existence Kardashev Type 2 or 3 civilizations, those capable of manipulating the energy of stars and galaxies. If 3I Atlas is their artifact, says Kaku, it could exist for billions of years until its orbit intersects a system containing observers like us. Despite the media's loud claims, NASA remains calm. Official releases state that no evidence of artificial origin has been found. Yet, in those same documents, one can read between the lines. The object exhibits a number of characteristics that merit further study. For an agency accustomed to speaking strictly scientifically, this is practically an admission. Meanwhile, 3I Atlas continues its journey. Its tail now extends 150,000 kilometers, and its brightness has fluctuated several more times. Telescopes are detecting unusual flashes in the blue spectrum. The reflected light is still stronger than that of the Sun in the same range. This is difficult to explain by natural causes. Such a glow does not occur in Earth's atmosphere. Some astronomers joke, if it's a spaceship, it's blinking at us, but too slowly for us to read the message. With each passing day, the line between science and hypothesis blurs. 3I Atlas has become a mirror, reflecting not only the universe, but also ourselves, our expectations, our fears, our thirst for something greater. Perhaps that's why this object so captivates the imagination. It's a reminder that space isn't a void, but a stage where the game is still going on, and the audience has finally noticed the spotlight. As 3I Atlas passed its closest approach to Earth, observatories around the world turned on their telescopes at maximum power. At that moment, science seemed to freeze in anticipation. Too much depended on what spectra and radio signals would reveal. On December 19, 2025, the comet passed at a distance of less than 1.8 astronomical units, and it became clear either we were on the threshold of the discovery of the century, or we were once again trying to explain the inexplicable. The first data came from Japan's Subaru telescope and the European Very Large Telescope Network. They confirmed that the object continued to accelerate, although the rate of evaporation was decreasing. This shouldn't have happened. If thrust was generated by the ejection of ice and gas, then the velocity should decrease as the evaporation mass decreased. But 3I Atlas was doing the opposite. It seemed to be receiving momentum from an unknown force. Some researchers cautiously suggested that this was the result of an internal energy redistribution. But in reality, such a term doesn't even exist in modern astrophysics. NASA published an updated report acknowledging for the first time that the comet's acceleration is not fully explained by standard models. For the agency, this sounded almost like an admission of helplessness. The same report stated that anomalous magnetic field fluctuations, weak but persistent, were observed in the tail region. They didn't coincide with solar storms and couldn't be caused by Earth-based instruments. It was as if the comet itself were emitting electromagnetic pulses. Then Michio Kaku entered the picture again. At a conference in Tokyo, he said, "We may be seeing proof for the first time of a plasma engine, whether natural or artificial. If 3I Atlas contains a structure capable of concentrating solar energy and using it for propulsion, then this is a technology we have yet to understand." The scientist emphasized that he wasn't claiming anything out of the ordinary, but if a rock can think in terms of physics, it's no longer just a rock. The journal Nature Astronomy published a paper suggesting that the acceleration could be explained by the Yarkovsky effect, a weak thermal radiation pressure. However, even there, they acknowledged that the effect's strength is too weak to explain the observed behavior. In the same issue, another team of researchers mentioned that the comet's direction of motion had changed slightly by fractions of an arcsecond, as if it had performed a microscopic maneuver. Perhaps this was simply a measurement error, or perhaps not. Meanwhile, astrophysicist Avi Loeb published a new note. If 3I Atlas accelerates without losing mass, it violates the laws of mechanics that we consider fundamental. And if the laws break, there's only one thing to do: rewrite them. His words spread across news feeds and sparked another wave of controversy. Some called Loeb a poet of science, others a provocateur. But he simply continued to insist when the facts don't fit the model needs to be changed, not the facts. Further observations revealed that 3 Atlas was gradually fading, although blue spectrum flares were still occurring. Infrared data revealed traces of emissions, but not the kind expected from melting ice. These were short, pulsed emissions, as if someone were turning a motor on and off. Their intervals matched the body's rotation, which is calculated to complete a full rotation in approximately 6.4 hours. The coincidence seemed almost too perfect. In January 2026, as the object was already receding, Physics World published a commentary by astrophysicist Julian Fenwick. We don't know what it was. Perhaps we observed a rare example of the interaction of a magnetic field and ionized gas. Or perhaps we just saw something that humanity will study for the next 100 years. 3I Atlas was moving away from the sun, but it left behind a trail of questions. Was it truly a natural body whose behavior simply defies our understanding? Or was it an ancient mechanism created by someone who lived long before us? The division between these theories became less scientific and more philosophical. After all, if we assume that this is a ship, even an automated one without a crew, then the very idea of loneliness in the universe ceases to exist. Michio Kaku said in an interview, "If 3I Atlas is a probe, it's not a visit, but an invitation. It's the universe's way of saying you're not the first." His phrase went viral. But behind the catchy quote was a thought: we too often look for life in the form of biological beings, whereas intelligence may take a different form, in the form of machines, systems, even comets, carrying within them a logic we're not yet able to recognize. And yet, even if 3I Atlas turns out to be just a comet, it has already fulfilled its mission. It has forced humanity to look at the sky again, not as a star map, but as a mystery. It has shown that the universe doesn't have to be understandable, and that an anomaly isn't a mistake, but an invitation to explore. When the final images showed the fading tail trail, like an artist's brushstroke, many felt a strange sensation, as if something enormous had just passed by, untouched, but leaving a mark on their memory. And perhaps that's precisely the point. 3I Atlas didn't arrive to provide answers. It arrived to remind them we haven't yet begun to ask the real questions.